Okay, welcome back. Now, in the previous video, we refactored our getBeamEndLocation function so that it uses our new function, which we called trace under crosshairs. We also added a new parameter called outHitLocation so we could update the hit location of the crosshair trace regardless of whether or not it actually hits something. If it doesn't hit something, outHitLocation is now the endpoint of the trace. Now in this video, what we want to do is we want to make sure that we're not even tracing unless we're close enough to the item, so that way we will only be able to display the widget if we are close enough and we're not tracing every frame when we don't need to be. We also want to be able to hide the widget as soon as we're no longer looking at it. In other words, when our trace hit is no longer hitting it. So we're going to do those things in this video. Now, just for a little bit of variety and also to get into a room that's free of clutter, I would like to change levels. I would like to go into our sci-fi interior. Now remember, this was one of the environments on the marketplace. This is in the permanently free collection. It's called Modular Sci-Fi Season 2 Starter Bundle, and it's got some environments here that we can use. So I've added this to my project. So here in Mod Sci Interiors, in the Maps folder, let's go to Example 2 Dynamic. Okay, so here I am in this level called Example 2 Dynamic, and this gives us a little bit of an open area that we can use to test out things. Okay, so let's get started with our code. Now I'm going to go ahead and get our base weapon folder open and drag in a base weapon. And I'll go ahead and bring this weapon over here so that it's up here in the light. And I'll go ahead and bring in a player start here. And I'm going to rotate it by 180 degrees so it's facing the weapon. And I'll have to bring it up here just a little bit. I'll actually bring the weapon over a little bit so that when I hit play, I'm not actually looking at it yet. And there we can make the widget pop up. Okay, so I only want to show this widget if I'm close enough. So right here, I would consider this to be too far away. And if I hover over, I wouldn't want this widget to pop up. And to do that, we can give our weapon a sphere component. And once we overlap with that sphere, then we can go ahead and start tracing for items. So we're going to add this sphere component to the base item class. So here we are in item.h in the private section, and we're going to add another variable. We're going to add a sphere component. So this is a forward declaration, and it'll be a uSphere component. That's a pointer, and we're going to call this area sphere. Now I want this to be edit anywhere, blueprint read only, category item properties. So we're going to give this the same uProperty specifiers as pickup widget. Now for the comment, we're going to say enables item tracing when overlapped. And we're going to construct the area sphere in the constructor. So just under our construction of pickup widget, we're going to construct area sphere. So area sphere equals create default subobject uSphere component, and we'll call this area sphere. And of course we can attach this to the root component. So area sphere setup attachment and get root component. Now, of course, we're using a uSphere component, which means we'll need to include the header file. So here is the documentation for uSphere component, and it has the include we need, component/sphere component. So we'll include this here at the top of item.cpp, and now that should get rid of the error that we're getting here. Now, we're going to want functions for overlapping and end overlapping the area sphere. We can set these up in begin play. So just under the pickup widget set visibility call, let's make a comment and say set up overlap for area sphere. So to set up overlap for our area sphere, we're going to get the area sphere and we're going to access an inherited variable called onComponentBeginOverlap. OnComponentBeginOverlap is a struct with the type fComponentBeginOverlap signature. It belongs to uPrimitiveComponent. Now, because AreaSphere is a uSphere component, it inherits from uPrimitiveComponent. Therefore, it inherits onComponentBeginOverlap. OnComponentBeginOverlap has a function macro called addDynamic. Now, if you start typing the parentheses, IntelliSense is going to autocomplete this with internal addDynamic, which is not what you want at all. So this is a case where IntelliSense is wrong. We actually just want addDynamic. Now, addDynamic allows us to bind a function to the onComponentBeginOverlap. Basically, this allows us to take a function address and store it so that anytime something overlaps with AreaSphere, that function gets called. And not only does that function get called, it receives all sorts of information pertaining to that overlap event. Now, the first parameter is a user object. We're going to pass in this because this is the object using this utility here. And next is the function name. So we need a function to pass in here. So we're going to create a function in item.h. We're going to put it in the protected section here. And this is going to be a void function called onSphereOverlap. Now, onSphereOverlap is going to be the callback function that we pass in to addDynamic here. So we pass it in, and we also need to use the address of operator because we're actually passing in the address of this function. So it can store this function by address, just like a pointer. Now, the callback function has to have a certain signature. It's got some input parameters because it's going to receive some information about the overlap event. So the input signature looks like this. uPrimitiveComponent overlapped component. That's the first input parameter. Next is an A actor called other actor. I'll put these on their own lines here. Next is another uPrimitiveComponent called other comp. Next we have an int32 called other body index. Next is a bool called b from sweep. And the last parameter is a const f hit result reference called sweep result. Okay, that is a huge function signature, isn't it? But that's because this type of function is required to be bound to onComponentBeginOverlap because onComponentBeginOverlap will pass in all that information to the function bound to it. In our case, it'll be our function onSphereOverlap. And we can use any of this information in our function, which will get called when something overlaps with our area sphere. Let's go ahead and create a function body for this. And now we have a function passed into onComponentBeginOverlap. Now you may be wondering how I just knew all of these input parameters. And the truth is, the way that onComponentBeginOverlap works behind the scenes is quite complicated. But to understand it at a high level, just know that it's a variable on AreaSphere because it's inherited from uPrimitiveComponent that has this function macro that allows us to take a function and bind it so that whenever something overlaps with this component, our function will be called. That's for overlap events. We can also create an end overlap event, and the process is similar. We say area sphere, and this time we access a variable called onComponentEndOverlap. And again, we call add dynamic. And we're going to have to click so we don't get IntelliSense autocorrecting us. And the first is the user object, and the second is the function name. We're going to have to create a function for this. So let's create it right here under onSphereOverlap, and we're going to call this void onSphereEndOverlap. Now the function signature for this one is shorter, but it looks a bit similar. The first parameter is a uPrimitive component called overlapped component. We'll put this on its own line. Next is an aActor called otherActor. Then another uPrimitive component called otherComp. And finally, an int32 called otherBodyIndex. And we can use this onSphereEndOverlap with the address of operator here. So onSphereEndOverlap. Now we can come back here and create a body for this function. And finally, one of the most important things with this whole process is these have to be U functions in order to work with this binding system. So we're going to just simply give these U function macros. So don't forget that part, otherwise they won't work. Now we can give these comments as well. I'm going to say for this one, called when overlapping area sphere. And for onSphereEndOverlap, we'll say called when end overlapping area sphere. Now we want to use these because we want to know if shooter character is overlapping any items so that it knows to trace for those items. So shooter character can keep a running count of the items that it's overlapping with, and if that number of items gets to 0, then we can stop tracing. So in shooterCharacter.h, in the private section, let's create a couple of variables. First, we want to create a Boolean to know whether or not we should be tracing for items. So let's make a bool called b should trace for items, and we'll comment this and say true if we should trace every frame for items. And I'll go ahead and initialize this in shooterCharacter.cpp up in the constructor up here. So b should trace for items will initialize to false. And I'll comment this item trace variables. So I'm going to create an integer to keep track of the number of overlapped items. Now this doesn't have to be a very big number. So I'm going to make this an int8 called overlapped item count. Now I'm going to give this a comment saying number of overlapped items. And we could say A items to specify. Now we're going to want a public getter for this since it's a private variable. So let's go ahead and create one. Let's make it force inline. It's going to return an int8, and we're going to call this get overlapped item count. It's going to be const, and it's going to return overlapped item count. Now I'm also going to want a function that can add or subtract to the overlapped item count. So this will be void, and I'm going to call this increment overlapped item count, and it's going to take an int 8 called amount. And so this will be the function that we can use to add or subtract to overlapped item count. And if the number of items that we're overlapping goes to 0, then we can stop tracing for items. So we can comment this function and say adds/subtracts to/from overlapped item count and updates b should trace for items. So we can get a function body created for this. And in increment overlapped item count, here's what we're going to do. We're going to check first to see if overlapped item count plus amount is less than or equal to 0. So if we increment this and we get 0 or less, well, we don't want it to be a negative number because it's a count. So we're going to set overlapped item count to 0. And we're also going to set b should trace for items to false. So if we set this to 0 or less, we'll make sure it's 0, so it's not negative, and we'll make sure that we can't trace for items. Now we'll have an else statement here, and the else will mean overlapped item count plus amount is positive. So we can say overlapped item count plus equals amount. And since overlapped item count is still positive, regardless of whether amount was positive or negative, we've added it and we still have something greater than 0. So that means we'll be overlapping with at least one item. So b should trace for items will be true. Now we can call this function in our overlap begin and end functions in item.cpp. So in onSphere overlap, first we're going to take our other actor. The other actor parameter in this function is the actor that overlapped with the area sphere and triggered the event. So first we check to see if other actor, and this first makes sure that other actor is not null. Now, all kinds of actors can overlap with the area sphere, so we need to make sure that it's the character that overlaps. So we're going to create a local aShooterCharacter variable, aShooterCharacter pointer called shooterCharacter, and we're going to set it equal to other actor cast to shooterCharacter. So we're going to say cast to aShooterCharacter, and we're going to cast other actor. Now, of course, we're going to need to include shooterCharacter.h. So let's put that up here at the top. Include shooterCharacter.h. And if this cast is a success, in other words, if shooterCharacter is not null, well, then all we need to do is call increment overlapped item count. And it looks like it's still not defined. So going up here, I see that I have one too many O's. So I'm going to delete that so it's actually including the right header file. Now, if shooterCharacter is valid, then we can call shooterCharacter increment overlapped item count, passing in 1, and so we'll add 1 to increment overlapped item count. Now, in the case where we have an end overlap, we're going to do the same exact thing, namely we're going to get the other actor. If it's valid, we're going to cast a shooterCharacter, And if the cast is successful, then we're going to take the character and call increment overlapped item count, but this time we're going to pass in -1 so that we'll decrease overlapped item count by 1. And that way, if we're the only item being overlapped, then that's going to set overlapped item count to 0, and also it's going to make shooter characters B should trace for items variable set to false. So now shooter character will have this boolean that will be true or false based on whether or not the character is overlapping with one or more items. So now all that's left to do is use this boolean to check to see whether we should be tracing every frame. So we'll go back up to tick, and in tick, right here, just before we do our trace, we're going to add an if check and check for B should trace for items. We're going to wrap all this in the if check. And one last thing before we test this out is I want to put all this in a function because tick should not be cluttered with a whole bunch of logic. We should only make a function call that will perform this. So I'm going to go to shooterCharacter.h and go all the way up to the protected section and create a void function and call this trace for items. And for the comment, I'm going to say trace for items if overlapped item count is greater than 0. So let's get a function body for this. And here in tick, I'm going to take this whole if check, I'm going to copy it, delete that, and paste it right here in trace for items. And then this is all we need to call here in tick. And I'm going to comment this and say check overlapped item count, then trace for items. And now we can see if this works in the editor. So let's go ahead and compile this. And I got a compile error, and that's because when I passed in the function addresses for onComponentBegin overlap, I forgot to fully qualify the name with a item and the scope resolution operator. Very important, you have to include that. So we'll go ahead and add that, and now we should be able to compile. So let's go ahead and compile this. Okay, so back here in the editor, I'm in base weapon BP, and here's our area sphere. Now we're going to want to make this area sphere big enough so that it will overlap with the character, but not too big because we only want it to activate the character's tracing ability when we're close enough. So select area sphere. And here's sphere radius. We'll go ahead and drag to the right to make this a little bit bigger. Let's say about here. And I'll go ahead and make this 150. And I'll go ahead and compile that. And I'd like to make area sphere visible. So let's scroll down and in the rendering section, uncheck hidden in game. And now we can see it in the level. So now we'll know that when we press play, we can tell whether or not we're overlapping with it. And you can see if I hover over the weapon, I don't get the widget. And if I overlap, then when I hover over the widget, we get the widget to pop up. So that's exactly what we wanted. Now that is going to conclude this video. It's already getting pretty long. So we now have overlap events that will trigger when we're close enough, and when we have our overlapped item count equal to something greater than 0, then when we look at the weapon with our crosshairs, then we get the widget to pop up. But if we start off and we're not close enough yet, then we do not get the widget to pop up. So we have to be close enough in order to get that widget. Now in the next video, when we're no longer tracing over the object, we want to hide that. Now here's a challenge for you. I want you to try to figure out how to make the widget stop showing on the screen as soon as we stop looking at it. As soon as we no longer trace over the object, how do you get that widget to go away? How do you set the visibility to false? I want you to go ahead and give that a try as a challenge. And in the next video, we're going to implement the solution to that challenge. We'll see you in the next video.